بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Math grade 6. We are in model 10, the last model in this year in grade 6, statistical measures and displays. Today we have the last lesson in this model, lesson 7, interpret graphing displays. Interpret graphical displays. Interpret graphical displays. In this lesson, we want to learn how to use content, a specific vocabulary to describe orally and in writing dot plots, histograms, and box plots. The first idea in this lesson, what the meaning of interpret dot plots. Listen, please.
Interpret dot plots. Teaching notes. The distribution of a set of data shows the arrangement of data values. It can be described by its center, spread, variation, or overall shape. Determining the symmetry of a distribution is one way to describe its shape. If the left side of a distribution looks like the right side, then the distribution is a symmetric distribution. If there is an outlier, the distribution is usually not symmetric. Select each card, see an example of asymmetric distribution and a distribution that is not symmetric.
We have two types of distributions. The place of the points in each number line means the distribution. As you see here, we have two figures. Here, symmetric. When you have here in the center, the right side equal the left side means we have symmetric. We have symmetric. As you see here, this is the center. Here the right side, here the left side. So the left side looks like the right side. Not symmetric, the right side different than the left side. As you see here the center, here the right side, here the left side. So the right side doesn't look like the left side. As you see here, symmetric. The right side equals the left side. The shape of data distribution tell you which measures of center and measures of spread are most appropriate to use. Is the data distribution symmetric? And if the data is symmetric, use the mean to describe the center and use the mean absolute deviation to describe the spread. If not symmetric, use the median to describe the center and use the interquartile range to describe the spread. For example, interpret dot plots. The result of class survey about the number of states visited by student are shown in the dot plot. Choose the appropriate measures of center and variation, then use the measures to describe the distribution. As you see here, we have the dot plot. As you see here, this is not symmetric. This is not symmetric. So the first part, choose the appropriate measures. Is the data evenly distributed between the left side and the right side? No. Is there an outlier? Yes, we have here the outlier 9. The data is not symmetric because the right side different than the left side. So we can use the median to describe the measure of center and the interquartile range to describe the measure of variation. So use the median and interquartile range to describe the measure of center and variation. The second step describes the distribution. As you see here, how many students responded to the survey? The number of dots will be 19. So we can find the median will be 2. So this indicates that the number of states visited by student can be summarized by the single value of 2 states. The interquartile range will be 3 minus 1 will be 2 states. This indicates the spread of the data around the center is about 2 states. Other than the outlier, there is not a lot of variation among the data. We have here outlier, but not a lot of variation among the data. As you see, we have big distance. The second idea in this lesson, interpret histograms. We have 3 new words here: cluster, gap, epic. Listen very well, please.
Interpret histograms. Teaching notes. You can also describe the distribution of histograms, including symmetry, clusters, gaps, and peaks. A cluster occurs when data values are grouped together. A gap occurs where there are no data values. A peak is the most frequently occurring value or interval of values in a data set.
Listen, please. What's the meaning of the peak? There is a peak from 400 to 499 feet here. The most frequency, the taller one. The taller one means the peak. What's the meaning of the gap? The gap means there is a gap from 800 to 899. So no data here, means no data here. What's the meaning of the cluster? There is a cluster from 400 from here to the 799 together, the data together. Example. The histogram shows the distribution in minutes and seconds of the solar eclipse over 10 years period. Use cluster, gaps, peaks, outliers, and symmetry to describe the shape of the distribution. The first step, identify the symmetry, cluster, and outliers. So, are there any outliers? No, we don't have outliers here. Is the distribution symmetric? No. The left side different than the right side. Are there any cluster? Yes. We have here the data together. Yes, we have clusters. There is a cluster from 01 to the 730. No outliers. The second step, identify any peaks. The more frequency or the most frequency. Yes, we have. Are there any peaks? Yes. How many peaks are there? Just one. there is a peak from 001 to the 230. Identify any gaps. As you see here, we have gaps, no data here. Yes, we have just one. The step 4, describe the distribution. The data is not symmetric and doesn't contain any outliers. The data cluster around 1 second to 7 minutes and 30 seconds and have a peak from 1 second to 2 minutes, 30 seconds. There is a gap from 7 minutes, 31 seconds to the 10 minutes. The third idea here, interpret box plots. How does a box plot reflect changes in a dataset? The average number of points per game scored by different players on a basketball team is graphed on the number line. We have here, as you see, the number line. Here we have number line, and here we have the data. So the median will be here, the quartals, the first quartile and the second quartile, the third quartile, and the box plot between the first and the third quartile. And here we have the interquartile range, and here we have the whisker between the lower and the upper values. So here we have the median, the first quartile, the third quartile, and the difference between them will be the interquartile range. And here we have the right whisker, the left whisker. The whisker means the distance between the lowest value and the first quartile, and between the third quartile and the upper value, or the biggest value. The last idea here, interpret box plots. Listen please here.
Interpret box plots. Teaching notes. Although a box plot does not show individual data values, you can still describe the distribution of data. Box plots are constructed using the median and interquartile range, so use those measures to describe the center and variation of the data. Because a box plot does not show individual data values, the mean cannot be found, unless the data are perfectly symmetric. In that case, the mean and the median have the same value.
See here we have number line. If we have symmetric, if the whiskers are the same length, if this length equal this length, means we have symmetric. And the median line segment divides the box into two equals. This is the median. The right side in this box equal the left side in this box. Then the distribution is symmetric. Then we can say the distribution will be what? Symmetric. If not symmetric, as you see, if the whiskers are of varying length, here different than here, and the distance here different than here, so this is not symmetric. And the outlier, if we have here value, so the outliers are represented by an asterisk. This means asterisk on a box plot. this symbol, asterisk. Whisker will not extend to outliers, but instead to the previous or next data values. For example, the box plot shows the daily attendance at a fitness club. Describe the distribution of the data, including asymmetry, outliers, measures of center, and measures of variation. And as you see, we have here the figure. So what is the median here? As you see, the median will be 70. Is it symmetry or not symmetry? The median segment doesn't divide the box into two equal boxes, so the distribution is not symmetric, because the distance here different than the distance here. The outlier, yes, we have here, the outlier will be 110 people, is indicated by the asterisk. The quartile range, we have here the first quartile and the second quartile. 80 minus 65 will be 15. This means that the middle 50% of the data vary by 15. Okay, this is our lesson today. This is the last lesson in the last model 10. See you inshallah next year. This is our lesson today. Thank you for your listening. Have a nice day. Assalamu alaikum wa rahmatullahi wa barakatuh.